team. The micro aerial vehicle designed by our team is here. I don't suppose it's not here. I'll have to make a little changes here. I hope it's gonna be there now. Anyways, it'll just come on to the screen now. This is our micro aerial vehicle. As well labeled, the micro aerial vehicle here has all the parts. It is a coaxial helicopter with twin motors powering the two counter-rotating rotors. These rotators these were custom-built rotors because the ones we purchased from the market, they were not fit enough for this mission, so we had to trim them down within 30 centimeters. The motors here are powerful 180 motors. These are two motors, DC powered motors. We have developed our own indigenous autopilot, and we feel immensely proud of ourselves for having been able to test it in a lab, and it actually worked really well. This autopilot which we have developed uses all the sensors, as in the GPS, the IMU to stabilize the whole system, and it also has the capability of attaching a camera to it and transferring it to using an RF module to the base station so that the operation can be further proceeded with. Moving on. We have named our MAV the Intruder. It has been very aptly named Intruder because we have used the camouflage technique. We have very aptly painted it so that it is able to hide within the obstacles like the trees and all, so that it can hover and proceed with its mission. Now, the sensors which have incorporated in a micro aerial vehicle are the GPS, as I've already told you, the inertial measurement unit, the camera. We also tried to incorporate the sound sensors, but for this mission we cancelled it because of the power constraints there. The future sensors which we are planning to incorporate in our MAVs are going to be the photoreceptors and chemical sensors. Especially we have been doing our research on the chemical sensors. Mr. Sushant Gupta, he actually developed a scheme for detecting mines using chemical detection. He proposed the technology, the QR technology, which means the quadruple resonance technology. In there, he actually we have proposed to send some sort of pulses to the mines, wherein the nitrogen will be activated and it will be reflecting back some signals. These echoes and signals will be detected using the QR sensors and will be processed for if it is a mine or not. This is the whole block diagram of the functioning of the micro aerial vehicle. It says that the microcontroller, it is receiving its data from the GPS module, the IMU module for the stability, the camera for being transmitted using the RF modem, and the RF channel which will be sending the data to the base station. Then we have also the kill switch in case the micro aerial vehicle is not performing to the expectations, then we can kill it anytime. This is the representation of the whole block diagram we just saw. As in, this is the microcontroller, which is the brain. We are using the Atmega 16 as the brain of this microcontroller, which will be serving as the brain of the autopilot system on the whole. Moving on. Now we have, as I've already told you, the indigenous autopilot which we have been able to build in our laboratories. If we have programmed it to be, as in, if it goes into the perimeter of area of 10 meters within the no-fly zones, then it has been programmed to either reverse back its path or go to the safe region, so that it does not get eliminated from the mission. We have made it able to go from one navigation waypoint to the other navigation waypoint. So the whole system has been made to be able to be completely autonomous, both the micro aerial vehicle and the unmanned ground vehicle. This is the micro aerial vehicle from the front view and the side view. Moving on. We'll now coming to the image processing. In image processing, the streaming video which will be sent from the micro aerial vehicle to the base station will be processed at the base station using a software in which the first scheme which we'll be using is going to be like determination of the scale space and the extrema detections, where the points, the pixels which we think according to software that these are not changing their orientations or their scales, even if the image is being oriented to a different angle. So these points are being called as key points. After going through such an algorithm, we come up with this is the software which we'll be using there. If suppose this is the image, this is suppose the signature of a hostage if kept in a building, and we know it has been oriented in a different manner, so the hostages can be in any manner. The arrows which you can spot if you can, yeah, you'll be able to. These arrows are actually determining the key points with their magnitudes representing their stability of their orientations and their scales. Moving on, if this is the image, which you can see right there, if this is the image which has been acquired using the microaerial vehicle or any reconnaissance system, then it will be sent to the base station and processed against the signature image we just fed. I just showed you earlier to this. So these are the key points of this particular image. Once processed and after sending it to the matching algorithm, we come with something like this. Here we can clearly see that both the images, the unoriented one, the acquired one which is on to the left hand side of the screen, and the signature image which was on the right hand side of the image, have successfully been linked. The lines which you can see are the successful key point matches. There are a few I'll say waste matches which will have to be deducted. So we are still working on as in how many successful match points we should be considering as successful match. So this was the image processing thing. Coming on to the UGV, this is our UGV, the unmanned ground vehicle. We have used an internal combustion part, the nitro fuel engine, the UGV, because we needed immense power to carry our payload, which will be carrying like a laptop for onboard processing, because our UGV also has onboard processing, the image processing capabilities. It will be able to navigate its own path. It is completely not autonomous. Once the autopilot has been programmed for navigation, it can go from one navigation waypoint to the other waypoint. Then it can as well it can acquire images and process the images as in is it walking on the straight path, and it can also see if it detects any mine by itself, it can go to that mine, defuse it, and go back and proceed with the mission. This is the block diagram, the basic block diagram of the UGV. It is almost the same as the microaerial vehicle, the microcontroller, which is the autopilot, the navigation waypoint, navigation program, which will be acquiring data with GPS and etc. Moving on. We have programmed our microcontroller to perform the task of navigation and the detection of mine. So it's like once the laptop, which is processing the images acquired by the camera of the UGV, and if it tests, yeah, it is a mine, then it will send interrupt to the microcontroller or the autopilot, it has to make it to go to that point or stop and maybe raise an alarm. In this particular mission, we had programmed it to raise an alarm. Yes, sir. Yes. Sir. But we were not able because of the wind conditions. We are using a coaxial helicopter. We were willing to demonstrate it, but the winds were gusting somewhere around 10 plus. So we were asked to demonstrate our best technologies. So we thought I'll take the suggestion. Thanks for your guys. Thank you.
Okay, thank you very much. The next